Hi everyone, it's Mrs. Caldwell. I hope you guys had a great weekend. I hope you enjoyed the partial nice weather that we had. This week we're going to look at solving rational equations, and good news, this is the last week of new material. So we'll look at solving rational equations this week. We'll review next week and have a quiz, and then review and have a test, and then you're done. So that's all we have left for Algebra 3. So let's get right into it. For the beginning, we're going to look at reducing fractions. So go ahead and take a minute, pause the video, reduce these, and then come back. All right, here we go. So for number 1, 3 over 9, we're going to look at what goes into both 3 and 9, which is 3. I can divide this by 3, I get 1. Divide this by 3, I get 3. For number 2, what goes into both 10 and 12? 2. I can divide this by 2, I get 5. Divide this by 2, I get 6. All right, and for number 3, what goes into both of those? 3. Divide by 3, I get 2. Divide by 3, I get 3. Okay, so just practicing some simplifying. Okay, so now look at the diagonals formed by the original fractions in its reduced form. All right, so if we look at 3 over 9 and 1 over 3, if we set them equal, the diagonals, we would get 3 times 3 and 1 times 9. If you notice, those are the exact same thing. 9 equals 9. And that's how we get this idea of cross multiplying. Okay, if we look at these diagonals here, A over B equals C over D, then A times D would equal C times B. Okay, and again, cross multiplying is how we're going to solve some of these equations. So today we're going to look at cross multiplying. Tomorrow we're going to look at solving with an LCD. Okay, so let's go ahead and solve here. So 3 over x equals 9 over 12. So we're going to look at cross multiplying. 3 times 12 equals 9 times x. So 3 times 12 is 36. 9x. I'm going to divide both sides by 9, and I end up getting x equals 4. Now, if you notice at the top, there's a big thing here about extraneous solutions. An extraneous solution is a solution that would make the denominator 0. So for this case here, what would make that 0 if x was 0? Okay, is x 0? No, it's 4. If I plug in 4 here, does that make the denominator 0? No. So that answer is okay. So we always want to check if x is in the denominator, whatever answer we get for x, it doesn't make that denominator 0. If it does, then we can't have that solution. All right, let's go ahead and look at the next one. Again, we're just going to do a quick cross multiply. 6 times 5 equals 3 times x minus 1. Now, I'm very careful to use parentheses because I want to make sure that I distribute everything here. So I'm going to distribute this 3. I get 30 equals 3x minus 3. Then I'm going to go ahead and add 3 to both sides. And then I'm going to divide 3. And I end up getting 11 for x. And when I check 11, if I plug that into this x here, 11 minus 1 is 10. That does not equal 0. So that solution is okay. All right. Go ahead and try C, and then come back and check with me. Okay, welcome back. Hope you tried this one on your own. And go ahead and make sure we have some parentheses here. So 2 times 2x plus 3, distribute, I get 4x plus 6 equals 20. Subtract 6. I get 4x equals 14. Divide by 4, I get x equals 14 over 4. but we know that we want to simplify our fractions. What goes into both 14 and 4? 2. If I divide by 2, I get 7 over 2. Okay. All right, so for example 2, it's the exact same idea, only now we have x's in multiple places. So when I cross multiply, I just have to be very careful of my distributing. So 2 times x plus 5, again, notice I'm using parentheses, equals 3 times x minus 3. And then from there, I'm going to distribute. I get 2x plus 10 equals 3x minus 9. I'm going to subtract 2x. And then I'm going to add 9. And I get 19 equals x. Again, I need to check my extraneous solutions. Make sure if I plugged in 19 to the bottom, I don't care about this top x. Okay, I don't care about checking that. It's only the bottom that can't be 0. 19 minus 3 is 16. That's not 0, so we're good. Okay, I think I forgot to do that for this one here. If I plug in 2 times 7 over 2 plus 3, I end up getting 10. I don't get 0, so that one was good as well. Okay. All right, I want you to go ahead and try B on your own, so pause the video, come back when you're ready. Okay, welcome back. We're going to go ahead and cross multiply. So I have 2 times 3x minus 1. Okay, then I'm going to go ahead and distribute. I get 3 times 2 is 6x minus 2. And I have 4x plus 8. I'm going to subtract the 4x. 2x minus 2 equals 8. Add 2. Divide by 2. And I end up getting x equals 5. Okay, again, check your answer. So here, 5 plus, oops, I don't know what just happened here. Let's try that again. 5 plus 2 does not equal 0. 3 times 5 minus 1 is 15 minus 5, which is 14. Neither of those equals 0, so we're good. Okay. All right, the last two answers, solving by factoring, just means that we're going to cross multiply, and after we cross multiply, we might have to factor. So when we cross multiply here, notice we end up getting x times x minus 1. Again, very important to have our parentheses, equals 4 times 3. So when I distribute, I get x squared minus x equals 12. Okay, I'm going to go ahead and add, I want to subtract 12 on both sides. You talked about this back in your quadratics unit, that when you have x squared and x, you want to get everything on one side equal to 0. If we make a factor box, we're looking at what multiplies to give us negative 12, and this is like having a negative 1 here. Add to give us negative 1, x. Okay, so that's going to end up being x minus 4 and x plus 3. The 4 is negative. The bigger number is negative because the negative 1 is negative. If I set each of those equal to 0, I get x equals 4 and x equals negative 3. But then again, I do have to check my solutions. Okay. Can x equal 4 and can x equals 3? Or I'm sorry, negative 3? Yes. Okay, again, this piece, this top piece, it doesn't matter what x is. Okay? The only thing that matters is the bottom x because it cannot be 0. All right, go ahead and try the last one. And then pause the video, try the next one. Check your answer when you're ready. All right, let's go ahead and go through this one. So when I cross multiply, I get 1 times that, which is just itself. X squared plus 4 equals 3 times x plus 4. Okay, so I'm going to go ahead and distribute. I get x squared plus 4x equals 3x plus 12. Now, since the x squared is on the left, that's where I want everything to be. So I'm going to move everything else to that side. So I'm going to move the 3x, and when I move that, it's going to combine with the 4x because those are like terms. I'm going to subtract the 12, but that doesn't have anything to combine with, so it's going to be by itself. So this piece here is going to end up giving me a positive 1, and this whole thing will become 0. Again, if I make a factor box, I'm looking at what multiplies to give me negative 12, but this time I'm looking at positive 1, adds to give me positive 1x. So again, it's 4 and 3, but this time it's positive 4. Again, the bigger number takes the sign of that middle number. Okay, if I set each of these equal to 0, I end up getting x equals negative 4 and x equals positive 3. Our last step is to check those answers. If I plug in negative 4, whether I plug it into the left, negative 4 squared plus 4 times negative 4, I get 16 minus 16, which is 0. If I plug it in here, I also get 0. I cannot have 0 in the denominator. That means that's an extraneous solution. So I am just going to cross that off. That answer cannot be possible. All right, if I try 3 squared plus 4 times 3 gives me 21, or 3 plus 4 gives me 7. That's fine. So 3 is my only answer that works there. Okay? All right, go ahead and try the assignment sheet that's attached to this. When you're all done, check your answers, and then go ahead and submit what you have for points. I hope you have a good rest of the day. I hope to see you guys on the Google Hangout, either Monday if you're period 1, Tuesday if you're period 2, and then I will post your last assignment, notes assignment on Wednesday for Wednesday, Thursday. Have a good day.